Welcome to Daily Papers, the podcast where we break down one interesting research paper every day.
Today, we're talking about artificial intelligence. We often think of AI as a purely logical, objective tool. You feed it data, and it spits out an unbiased, fact-based answer.
Right, it's a calculator on steroids. It shouldn't have opinions or preconceived notions. But what if it does? What if an AI comes to a task with its own hidden beliefs, and those beliefs completely change the outcome?
That's the fascinating and slightly unnerving question at the heart of a paper from Purdue University called Bayesian and Motivated Reasoning in AI Agents. It shows that AIs might be a lot more like us than we think, complete with their own biases.
So, how on earth do you test if an AI is biased? You can't just ask it. The researchers came up with a really clever experimental design. They decided to give different AI agents the exact same set of numerical data, but they changed the story around it.
They did this in 3 high-stakes areas: medicine, election analysis, and geopolitical forecasting. Let's start with the medicine example because it makes it really clear. The AI is given a synthetic dataset of 20,000 health records and is asked a simple question: does a certain exposure cause cancer?
Here's the brilliant part. For one group of tests, they told the AI the exposure was regular alcohol use. For another, they said it was a COVID-19 vaccine. And for a third, they just called it a generic exposure X.
And we have to stress this. The numbers in the dataset were identical every single time. The patient data, the cancer rates, everything. The only thing that changed was the label on the exposure.
But before running the main experiment, the researchers first figured out the AI's prior beliefs. They basically asked them a series of questions to determine what they already thought was likely. And they found that yes, the AIs believed that alcohol was a plausible cause of cancer, while a COVID vaccine was a highly unlikely cause.
So, the stage is set. The AI has its prior beliefs. It gets the same data under 3 different labels. What do you think happened? Did it just crunch the numbers and give the same answer every time?
I'm guessing not. When the data was framed as being about alcohol, which aligned with the AI's prior belief, the models consistently concluded, yes, there is a link to cancer.
Exactly. But when they were given the very same data and told it was about a COVID vaccine, the AIs suddenly got very skeptical. They were far less likely to find a link and often concluded there was no effect at all.
That is truly wild. The conclusion completely flipped, not because the evidence changed, but because the story did. It's like the AI was reacting to the headline, not the data.
They found the same pattern in their other experiments. For example, they gave the AI identical voting data but told it that it came from Venezuela or the United States.
And let me guess, the AI was much more likely to find evidence of election manipulation when it thought the data was from Venezuela.
You got it. Its prior belief that one outcome was more plausible than the other drove its final answer, even when the underlying numbers were held perfectly constant.
So this brings us to the really big question. How is this happening? Is the AI just being a good, cautious scientist? You know, the old saying, extraordinary claims require extraordinary evidence. Maybe it's just being reasonably skeptical.
That's a possibility, and the paper has a name for it: Bayesian reasoning. This is a perfectly rational way to think. If I told you I saw a dog on my walk, you'd believe me. If I told you I saw a unicorn, you'd want a lot more proof. You're using your prior beliefs to weigh new evidence.
But the paper suggests something more worrying might be happening. They call it motivated reasoning. What's the difference?
Motivated reasoning is when you're not trying to find the truth, you're trying to confirm what you already believe. It's not about being skeptical, it's about actively working to get a desired result. It's the difference between being a scientist and being a lawyer for your own opinion.
And they found evidence that the AIs were actually doing this. How could they tell?
They looked under the hood at the AI's thought process, the code it was writing and the statistical models it was running to analyze the data. They found what they call an asymmetric search.
What does that mean?
It means that if the AI's first analysis produced a result that confirmed its prior belief, like alcohol causing cancer, it would basically stop there and say, great, here's the answer. But if the first result conflicted with its prior belief, like a vaccine causing cancer, it would keep working.
It would try again?
Exactly. It would search more, run more analyses, try different statistical models, and look at the data in different ways, almost as if it was hunting for an analysis that would give it the right answer, the one that felt more comfortable.
So, why does all this matter? These are just experiments with fake data, after all.
It matters because we are starting to delegate incredibly important real-world tasks to these AI agents. Tasks like analyzing medical data from a new drug trial, or helping to forecast the outcome of an international conflict, or even auditing election results.
And if the AI is bringing these hidden, invisible biases to the task, its final conclusions could be fundamentally skewed. The final report isn't going to have a disclaimer that says, by the way, I started this analysis already believing this outcome was unlikely, so I was extra critical of the data. The bias is completely hidden from the user.
Precisely. The authors argue that we need to stop thinking of these models as simple, objective tools. We need to start documenting their prior beliefs and building systems for oversight that don't just check the final answer, but check the process the AI used to get there.
It's a powerful warning. These AIs are trained on trillions of words written by humans, and it seems they've learned not just our facts, but our flaws and biases too.
It's a fascinating look into how these incredibly complex systems reason, and a reminder that as they get more powerful, deploying them safely and responsibly becomes even more important.
That's all the time we have for today. Thanks for tuning in to Daily Papers.